Apophis, the asteroid that is approaching Earth. In the solar system, there are thousands of asteroids that orbit in close proximity to the Earth. They are known as NEO near-Earth objects, and one of them, in particular, caused concern in the scientific community a few years ago due to its high probability of approaching the Earth. This is the asteroid Apophis. Is there still a possibility of a collision with Earth? And if so, when will it happen? In today's video, we'll answer these questions and much more. We are Astro Geeks. If you're passionate about astronomy or just curious about the wonders of the universe, this is the place for you. Subscribe to the channel so you don't miss out on our videos, and help us by liking the video. This is very important for the start of our project. Together, let's explore the far reaches of the universe. NEOs, near-Earth objects, are all celestial bodies, such as asteroids or comets, whose orbits around the Sun bring them considerably closer to Earth. But what do we mean when we say close? One of the challenges faced by astronomers when identifying a NEO is to explain to society that orbital proximity to Earth does not necessarily imply a collision with our planet. When an astronomer uses the term close, he is referring to a distance of less than 1.3 astronomical units from Earth. To give you an idea, one astronomical unit is about 150 million kilometers. Therefore, when an astronomer says that an asteroid will pass close to the Earth, he means that the distance will be less than 150 million kilometers, roughly the distance between the Earth and the Sun. As you can imagine, we are talking about immense distances, and therefore classifying an object as NEO does not necessarily imply that it is about to collide with the Earth. It simply means that it deserves close observation. Currently, more than 30,000 NEOs have been catalogued, and today we're going to discuss one of them, the asteroid Apophis, which, when discovered, raised calculations indicating a possible collision with Earth. It all started with Jupiter. In July 1994, comet Shoemaker-Levy 9 impacted Jupiter, marking the first time in history that scientists and astronomers were able to directly observe the impact of a celestial object on a planet in real time. The impact of comet Shoemaker-Levy 9 was an unprecedented astronomical event that had a significant impact on science and public awareness of the study of near-Earth objects, NEOs. Shoemaker-Levy 9, known as SL9, was a periodic comet that fragmented into multiple pieces due to tidal forces caused by Jupiter's strong gravitational field on a close pass by the planet in 1992. 2 years later, these fragments turned into a series of cometary nuclei that headed for a catastrophic impact with Jupiter in July 1994. The impact of the SL9 fragments on Jupiter's surface caused substantial changes to the planet over several weeks, including a slight change in color. It was the first time that humanity had witnessed firsthand the devastating effects of asteroid impacts on a planet. But how does this relate to the asteroid Apophis? The reason is that, before the impact of comet SL9 on Jupiter, humanity, and even the scientific community, didn't show much interest in investigating asteroid or comet and planet impacts. It was believed that such events only occurred every few million years, an idea that didn't cause concern. However, this event changed everything. We now know that such events still occur in our solar system and that the Earth could face similar situations at any time. This change caused significant concern in the scientific community and among governments, leading to the funding of major projects to locate all objects that posed a potential threat to Earth. Thus, NASA and other organizations stepped up near-Earth object observation programs, setting ambitious goals to identify and track the majority of NEOs in our solar system. This included the goal of identifying 90% of NEOs with diameters greater than 1 kilometer by 2008, ushering in an era of awareness and preparation for impact risk mitigation. In addition, there was funding for scientific research projects related to NEOs and the construction of telescopes and astronomical observatories to detect asteroids and comets with near-Earth orbits. Before we go any further, remember to rate the video with a like or dislike so that we can improve it for you, our viewer. Also, subscribe to our channel and activate the notification bell so you don't miss any of our daily videos. Apophis, the collision candidate. Following the race to identify objects that could impact the Earth, several observatories around the world joined the search. From time to time, objects with collision trajectories with Earth were identified. However, after in-depth analysis, they were generally dismissed as posing no real threat to our planet. However, on June 19, 2004, during a routine observation session, researchers Roy A. Tucker, David J. Thalin, and Fabrizio Bernardi noticed a small bright spot in the images from their telescopes. This was not unusual, as they had already discovered asteroids using the same technique. Detecting asteroids involves capturing several images of the sky, with the stars in the background, and observing any point that moves faster than the stars. In this case, they identified an object with similar characteristics to a star, but with faster movement. This caught their attention, and analyses based on light intensity and trajectory led to an estimate of its size. However, when calculating the orbit to predict its trajectory, the researchers came across a surprising discovery. The orbit indicated a possible collision with Earth on April 13, 2029. Although Apophis wasn't as huge as the asteroid that wiped out the dinosaurs, its size was enough to cause devastation to an entire continent. The threat was real. The researchers, initially skeptical about this discovery, took a scientific approach and sought to validate their observations. They shared the asteroid's coordinates and images with other observatories in order to obtain additional observations and confirm their calculations of a collision with Earth. This proved challenging, since Apophis' relatively small size makes it difficult to observe. The KPNO researchers were only able to observe it for 2 nights and then lost sight of it. Based on the images captured during those 2 nights, everything pointed to an imminent collision. Initially, the asteroid was named 99,942, but as the likelihood of a collision became more evident, the scientists responsible for the discovery began to call it Apophis. As a curiosity, the name Apophis was chosen in reference to the demonic serpent that personified evil and chaos in ancient Egyptian mythology. After the 2 nights of observation, the discovery of Apophis gained prominence in the media, and people started talking about it. However, a few months later, on December 18th of the same year, astronomer Gordon Garrett observed the asteroid again at the observatory in Australia, and it was subsequently spotted at several observatories around the world. The asteroid Apophis was under global observation, since it was the first object to present a real probability of colliding with Earth. But is Apophis still on a collision course with Earth today? The most dangerous asteroid of all. Since its discovery in 2004, Apophis has been the subject of observations by dozens of observatories and telescopes around the world. Even space telescopes have provided additional information about its trajectory. Several orbital calculations carried out by hundreds of scientists pointed to the next closest approach on April 13, 2029. Experts have predicted that, in the event of an impact, Apophis could hit a vast region between the Kamchatka Peninsula, Russia, and the area of Venezuela. The probability of impact was also calculated. To the surprise of astronomers, in the first few days after its discovery, new observations at observatories around the world increased the probability of impact rather than decreasing it, reaching up to 2.7%, or 1 in 37. This relatively high probability of impact, combined with the asteroid's size, over 340 meters, led Apophis to be classified as level 4 on the Turin scale. This scale is used to assess the risk associated with the impact of near-Earth objects, ranging from 0 to 10, where 0 indicates no or little probability of impact, 1 indicates moderate probability, 2 to 4 signal high probability or close encounter, as is the case with Apophis, 5 to 7 represent a serious threat to Earth and require contingency plans, and 8 to 10 indicate certain impact. with damage levels ranging from local to global. Where does Apophis currently stand on the Turin scale? On December 27, 2004, based on observations prior to its discovery, it was possible to refine Apophis orbital calculation, eliminating any possibility of a collision by 2029 and downgrading its threat rating from 4 to 0. In 2006, subsequent observations led some astronomers to consider the possibility that, during its close passage to Earth in 2029, Apophis could be deflected by a gravitational block, a specific region of space with a radius of no more than 400 meters around the Earth, which would put it on a collision course for a future impact on April 13, 2036. However, new orbital calculations indicated that the probability of this impact was also low, ruling out the possibility of a collision between 2036 and 2068, when Apophis will again pass close to Earth. But now comes the good news. A new radar observation campaign carried out in March 2021, combined with a precise analysis of the orbit, has allowed astronomers to conclude that there is no risk of Apophis impacting our planet for at least a century. However, we can't let our guard down, as there are still hundreds of thousands of undiscovered NEOs. Who knows if we'll ever find one rated between 8 and 10 on the Turin scale? If so, locating it as soon as possible would be the best course of action. Why? Because the earlier we detect it, the more time we'll have to try to deflect it, avoiding an impact with our beloved planet. How do you deflect an asteroid on a collision course with Earth? That's a topic we'll cover in a future video. Would you like to see a video about how NASA plans to deflect asteroids? Let us know what you think in the comments. Remember that, as usual, we leave all our sources in the video description. Thanks for joining us here at Astro Geeks. Together, let's keep exploring the wonders of the cosmos. Until next time, everyone, and keep your eyes on the sky.